Okay, it's 5:02 p.m. Excellent. 5:02 p.m. And it's December 29th, 2023. We're coming up on the end of the year. And I finally decided to learn a new programming language. New to me, anyway. I've known about it for a long time, but diving in, especially back when I first learned about it and where I was, didn't really make a whole lot of sense. You know? I was just a little bit irked by the explosion of languages that occurred around 2014 with Go, Swift, D, Rust, and many others popped onto the scene. Why learn one over the others, right? Like, you could easily, certainly dabble with each of them long enough to learn positives and negatives about them, right? And you really won't know anything until you actually start to try and build things, really understand your use cases. Not everything is a nail. Not every tool is a hammer. Not everything is a nail. There's a lot of different ways to think about the process of learning any new technology, in particular a new programming language. In my case, because C is, one of my favorite languages, why Rust, right? Why not stick with Go? Why not give myself, a bit more flexibility when it comes to development? Let's see. How can I switch to creator mode? Hey, Dope. Just now seeing your chats. I don't know where it is that you live, where you're going to bed so early all the time, dude, but glad you were able to make it to the stream. Just barely getting rolling here. It takes me all fucking day. I gotta get up earlier. That's the only way I'm gonna be able to do it. I have to go to bed earlier, and I have to wake up way earlier. I'm getting pretty good about getting the coffee ready beforehand, but timing is everything. Like, one of the first things I have to do in the morning is take my grandma's dog out to pee. She's old. Like, really old. Like, 13 plus. Blind in both eyes. And can't really get around on her own. As soon as she is placed anywhere once taken off grandma's bed, if she hasn't gone to pee, she's going to go pee. So first thing I do in the morning is take her out and make sure that she's taken care of before I try to snag a couple hours unbothered at my computer with some coffee and just start stretching and doing my thing and waking up a bit. Because after that, grandma's eating like every 2 hours almost. Not to mention the bathroom breaks. Not to mention requests for more coffee. And all of this makes it really difficult for me to stay at my computer long enough to really get anything done. I'm lucky that I've been able to find the few bugs that I've found, and that I've been able to reverse engineer a site for scraping and build some tools to clean the data that I scrape. And I'm real lucky to be able to squeeze all that stuff in, because this is really the time of year where I should be relaxing a bit more. And I find it very difficult to do that lately. So maybe what I need to do is grind out some code, get myself back into the seat of building things, and smashing it out when I can, because time is definitely of the essence, and you don't want to spend your life learning new languages so much as learning enough of one language or enough languages to build whatever it is that you want to build, and go from there. Sometimes you might find that another language is a better choice. Sometimes you might find that the system that you built could have been designed better. It's largely a game of like carefully evaluating your choices, because some people subscribe to certain philosophies. Like, for instance, I am a kind of a fan of build fast and fail often, because it is true that no successes can come without failures, without luck. If you try something and you succeed your first time, can you not say that you're not lucky? If you succeed 5 times in a row without failing, or if you succeed 100 or 1,000 times in a row without failing, at what point is it no longer luck and it's actually skill, right? What is it to say that, a person may or may not be good at building things or implementing things or figuring out the syntax over time, but there's a difference between that and being able to communicate what you're able to do. And this is certainly an area I struggle with. I've always found it easier to like sit down and work things out before I explain them, which has been largely backwards to the way that many tech organizations and companies actually perform interviews with engineers. They expect you to explain things first before you write things. And for most of my life, I write first, then explain after. Mostly just because I've been nonverbal for a lot of my initial time growing up, learning how to write code. I didn't have anyone to talk to about code, and anyone I was talking with about code, like even in high school, like even with teachers, I didn't find myself saying things about code so much as actually just doing it. It was a lot easier for me to just type something on the computer and show the teacher what I did rather than say what I did, because I didn't quite have the muscle memory or something to articulate the words, because even though internally I knew what I was doing, I didn't have the verbal communication skills to reflect this. But I think my teachers got that. Like, some of them even communicated with me in email and chat, text messaging. And this made things a lot easier. I think it, for the areas that I did know how to speak about, chat about games with friends, chat about anime and fucking cartoons and shit, stuff you actually know how to talk about. As for a lot of people, you're just sitting in class and just grinding through shit trying to get it done because you don't really care about it. You don't really care about class. You care about school, right? Like, unless you actually really were interested in whatever subjects it is that you were struggling with or whatever, um, chances are you never gave a shit enough to, like, talk about it, you know? Yeah, it'd be like, for instance, a fan of history or like the Civil War or World War II in order to actually talk about it. Because chances are you probably hadn't put enough investment into reading about it, to speaking about it with other people, to have that verbal muscle memory built in where you can just fire off shots and stuff would stick right away. Um, so let's talk about quines, because I actually can talk about those. What is a quine? So in a previous stream, I explained that a quine is a computer program that prints out its own source code. That's all it does. It doesn't say anything about how that source code gets printed out, though, which is where a lot of the fun comes in. So the fun aspect of working with quines is that you can format them to look like different things. So it's kind of an extension of ASCII art if you look at it from one perspective. The the most basic quine will just be like the one line quine with no formatting, right? But like other quines can be made, for instance, in different shapes and different structures. People can spell out words. People can draw different symbols and image representations. And a lot of this functionality that allows you to print these things out in these different formatted ways is dependent upon logic that you have to write yourself and embed into the quine. So that's how we get a lot of these cool different things that you're able to do. One of the things that I'm working on at the moment, let's just dive right in. If you take a look here, I've got a new iteration of the Rust quine that I've been working on in previous streams. So something broke here. Oh yeah, we haven't fixed this yet. 162 trying to unwrap. So we're going to fix this code real quick. When you're doing like a 4K in index through something.length.loop, the K is actually a U-size data type, which is probably 64 bits. And I'm working with a I-32 here, so let's see where was that line at? It's not exactly a 1-to-1. Let new line count. Okay, so it didn't compile again. So we're going to go ahead and fix this. Where's that unwrap at? Okay, so instead of doing this weird K trying to unwrap thing, perhaps we can do like let KK equal K trying to unwrap, and then pass KK directly into there. Maybe we can declare it to be an I-32 right away. That didn't look like it compiled. We got some error. Is it from... So on 13 and 14. Yeah, so... maybe we can make this a U32. Or we can make it a U size. Mismatch types. Oh, whoops. Oh. Okay, it compiled. Sweet. Okay, we got some warnings, and a lot of it's just about unused variables. Unused, unused, unused. Variable doesn't need to be mutable. So here's what we get. This is the whole program printing itself out, and we're attempting to introduce multiple formatting rules in order to create more, like structured looking outputs. As you can see, the first 10 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, are just regular old block style formatting. Any place that we're able to new line, we new line. Otherwise, we just print the character directly out. This is still a valid Rust program, so we can prove this by writing the source out to main.rs, and then by cargo building. Let's take a look at our main. This is what the main looks like right now, and we actually successfully compiled it just now, so we're able to run that. And we can diff source main with our test that we just outputted and see that they're the same program. Now, how did I do all this? This is the original source code with actual formatting, so we can read it pretty easily. And I've started to break things up into multiple functions. So that way it makes it a lot easier to do different things, because ultimately the rule processing is character dependent, and you want to keep track of certain state values while you're going through your program. As an example of this, how do we know to like shift from printing just like one column, as we do up here, to printing 2 columns, as we do down here? So let's take a look at that. We introduce a couple new variables. One of them is called max columns, and the other is called current columns. And previously, we were tracking current row, which I put in there ahead of time, anticipating that I was going to get to this point. So what you end up having to do, because we're not working with them as globals, is you have to pass them in as additional parameters to the functions that you create, when necessary, of course. One thing that we do every time we print out a new character, or we handle it, is we want to recalculate how many new lines there are remaining in the program, and this is in anticipation for a step that's to come later, which is swapping back from printing 2 columns when we're near the bottom to just printing a single column. And this way we'll be able to create a nice big square-like structure with a giant hole in the middle. And this will be our first target complicated structure beyond what I'm doing currently, because this is just the logical step past your single tower quine, is to get 2 tower quines, which we did in the previous video, or previous stream. The next step is to join these 2 ideas together, but in order to do this, we have to keep track of like how many new lines remain if we were to continue printing out in the current mode, because when we're a certain number of new lines away from the end, we want to switch back to printing single columns. So how do we do this? Let's take a look at what I'm doing first currently. So our main is now very short. This is what it looks like. And so it's very clean, and the primary loop is right here, where we process each character, and we have 3 cases. So after we calculate the new lines remaining, we check to see if the current character that we're handling, is it a new line? And if it is, then skip it. Just go to the next character. If the character was the add symbol, which is represented right here, this is our program array with all of the integer content representing our program itself. So we have a special function just for that, because any processing rules that we do, for instance, to handle both the single and the double columns, has to be handled in the print array as well. So anything that we do and handle special character, which is basically every other character's potentially special character, any special processing rules that we do, we have to also do when printing out the character array. So we have to keep this in mind, that you're going to end up having to place the logic in 2 separate areas because it's operating under 2 separate contexts. So what are we actually passing to these functions? So what is I? I is the current place in the current tower or column that you're currently printing out. So if you're working in a row that's part of a one big single column, it's just going to be your current position in that row. But if you're working in a row that has 2 columns, for instance, then it represents your position in whichever tower you happen to be printing out at that moment. When you finish printing out one tower and you do the spaces, you reset I to 0 so that when you begin printing out the next tower, it's like the position of the tower that you're currently printing. Current row naturally represents which row of the Quine we're currently printing. We keep track of this by incrementing it every time we encounter a new line. V is, of course, our program array. Current columns is which column, and actually this should be current column. Current column represents which tower you're currently printing out, and we're currently keeping track of whether or not you should be printing out single or multiple towers based off of what the current row is and how many, well, currently based off what the current row is, but we're going to be adding rules in so that when we're, say, 10 new lines away from the end of the program, that we're going to start printing out single columns again. We're going to do this by introducing another if statement into both of our functions here. Max columns is currently unused, but it's going to naturally represent how many columns we should be printing out, because we'll be able to modify this program to print out multiple columns, which we should be able to leverage in order to do different things like print various symbols, shapes, and whatnot. We can even upgrade this by adding in a function that prints out just a specific row in a certain way. But at the moment, we're doing everything on a character-by-character basis. So let's take a look at handle special character. This is where the meat of the code is. Of course, C is our character that we're printing out. I is our tower position. Current row is our current row. We keep track of whether or not we're inside quotes, because if we encounter a quote character, we have to account for this because we don't want to mess up the string that we're printing out. So if we're inside quotes, then we turn off a lot of the rule processing in general to finish printing the string, and then once we're outside the quotes, we can get back into special rule processing again. Current column, of course, is our current column, and max columns is the number of columns to print. So handle special character, thankfully, is also very small as a function. We print out the character itself, whatever it is, from our array. We increment I by 1, and then if the character that we just printed out happens to be one of a certain set of characters and there's more to add to this list, certain characters in Rust can be preceded by arbitrary numbers of white spaces, just like in C. This makes it very fun because you can format your programs to look like whatever you want, provided that you provide the program logic to do so. Naturally, you could sit down and try to handcraft something and cheat using a bunch of comments and repeating character symbols and stuff like that, but we're better than that. So we're going to have all of our drawing logic embedded into the program itself. So if our character is one of these characters, then we pass our variables to the handle special character spacing function. And if the character was a double quote, which is ASCII character 34, then we set is inside quotes to be not is inside quotes. One of the things that we have to do, because is inside quotes is a mutable reference, is we have to first dereference the value in order to get the raw Boolean it represents, right? Then we invert it by using the not symbol, which is the exclamation point, and then we reassign that to the location is inside quotes by dereferencing the location, which allows us to just hard assign it. We have to do that with our integer as well, I. This is not too different from C, honestly. It's very similar to how pointers work. So if you understand pointers as references, migrating over to Rust isn't so scary. It's more knowing when you have to use the mutable set, like the MUT keyword. It's most often going to be, especially in these instances, you put ampersand MUT to declare this as a mutable reference to an I32 data type. So, handle special character spacing. So here's that function. I'm currently hard coding in max rows, which we can easily extend this to be passed in from as a global. So we're doing that with constant length, or sorry, column length, which technically this should be actually column length we're currently hard coding in. It's actually a global. And when we're printing the two columns, we're currently hard coding the size by telling it to be 1/4 of the original length. So if the current row is less than max rows, and I is greater than or equal to column length, so in other words, we've printed past the end of the column, then if we're not inside quotes, then we new line, we increment our row, and we reset I to 0. Very straightforward. To get the split column effect, if current row is greater than or equal to max rows, and max rows is like 10, and I is greater than or equal to column length divided by 4. So for the first tower, we've printed 1/4 of the original tower's length, right? And if the current column is 0, so in other words, we're on the first tower, then we go ahead and print however many spaces. In this case, we determine that to be half of the original column length, because we've already used up 1/4 of it, right? And it's possible that we used just slightly more than 1/4, actually. So we take that difference, we take the I, whatever that value was, before we reset it in the next line, and then we subtract off whatever the 1/4 length of the original tower is, in order to get the difference in slightly going over 1/4 length, right? So that gets us exactly how many spaces that we want to print in order to start printing at the beginning of like 3/4 of the original tower length to get that second tower position. Then we increment our current column by 1. This is logic specifically for 2 columns. So if we wanted to extend this, we would have to do a bunch of extra shit. But we're just going to focus on closing up that loop at the bottom so that we have a nice donut shape. Square donut, but still kind of a donut. In current column equals 1 case, or the else case, we go ahead and new line, and then we increment our row, and then we reset our column, and we reset our I. That's it. So print array has been updated. It's no longer so brutally long because we've managed to wrap up the array spacing function, which is just like special char spacing. The only difference is it's when we're printing the array as opposed to when we're printing the rest of the program. When we're printing the array, we have to we have a lot less that we have to work with, but we still have to keep track of certain things. And if we want to extend the logic to wrap up that loop at the bottom, we're going to have to update this code too. So thankfully, the two primary case if statements, or if statements that we're dealing with, follow the same logic. If the current row is less than max rows, and I is greater or equal to column length, then we increment our current row and we set I to 0. If we're on the next row, if we're on the next state, which is current row is past those first 10, and our I is greater or equal to column length divided by 4, then if the current column is 0, then we go ahead and print out spaces by handling spaces. Now what this does is it takes the number of spaces and it prints it out. Now we only want to handle array spacing in certain cases, right? So immediately after printing out the first bracket, we have to increment I by 1. And then we have to see if I happen to trigger anything requiring spacing. So we call the handle array spacing function. When we print out the next number, because we can't put spaces in between the digits of a number that we're printing out, but we can put spaces in between that number and its comma that comes next, right? So if the number was 3 digits, we increment by 3. If it was 2, we increment by 2. If it was 1, we increment by 1. But then we call handle array spacing again. Anytime we increment I, we're going to have to call handle array spacing. And we pass all these things in because they're going to be necessary to determine what sort of spacing that we need to perform. So as we're stepping through the integers of this array, if j is still less than if like we're not on the last character or the last number of the array, then we want to print out a comma after we've printed out whatever number and we've done any spacing. Then we increment by 1, and then we call handle array spacing again, because it's still possible that after this call nothing happens, but then the next character sets us at that limit, and then we need to actually do the spacing. Then we print out our final bracket. Once we're on the last, after we finish the last number, we increment by 1, we handle spacing, we print the semicolon, increment by 1, and handle spacing. So handle array spacing and handle special character spacing follow very similar logic. The only difference is that handle special character spacing only gets called once inside the handle special character function, whereas handle array spacing gets called many times in print array, but all we have to do is update the logic of these two functions in order to do any sort of creative, crazy sort of shit that we might want to do here. So the goal right now is to we're going to have to pass in our new line count. So both print array and handle special character are going to have to accept another parameter, new line count. So print array and handle special character. Okay, so now we have the the parameter being passed to our functions, giving them access to it, but we're not doing anything with it yet. Naturally, we're going to have to pass it to handle special character spacing, which means we're going to have to add it as a parameter. Now we have access to it and handle special character spacing. And print array is going to have to pass it to handle array spacing. Let's see here. Handle array spacing, new line count. Let's see. Oh, yeah. So the whole deal here is that every time we call these functions, the correct updated new line count gets passed in. So as we're iterating through the array, or as we're iterating through each character in the program array, we're looping back through the program array to count how many new lines remain. Like if we were to follow the same processing rules. And in fact, we'd have to update this as well in order to follow the same rules. So we'd have to call this like handle new line I update. Let's see, I is a mutable 32 and count is a mutable I32. So every time we have to update the I, it's going to get reset to 0, and the count is going to increment by 1. Because these are references, we have to dereference them every time we do that. Handle new line I update. Now, one thing you'll notice is that all of these handle new line I updates are occurring inside of a if I greater than or equal to column length check. So we can actually take advantage of this by eliminating it here, and then adding that check to the if statement itself. Now we can actually eliminate several of those if statements. So for printing the @ symbol, these are all the rules for the new lines. If we happen to get a special character and we're inside quotes, we're not inside quotes, then we perform the same update. So these are the old rules, it looks like, because this doesn't take into account the spacing. So we can just kind of hold on to this for right now. Let's see. So that's count new lines. That gets called and for handle special character, so if we have less than or 10 new lines remaining, we will execute the same rules as the first set of rules for the first column. Um, handle array spacing. So same idea. Alright, moment of truth. Oh snap. Okay, so it actually broke the end there. Oh yeah, so naturally we also have to do this. Okay, so it still didn't quite... Oh, that's just the spacing. Hmm. Current row is less than max rows, or new line count is less than or equal to max rows. This line's not triggering, which means there's a problem with new line count. I is greater than or equal to column length, and we increment I by 1. Oh, that's never triggering. Or if C is 64, we do all this. Do all this. Oh, the is inside quotes might be messing it up, actually. Oh. Oh, we have our own local one. Oh, okay, never mind. Why do we increment one here? Oh, for the last... Oh, that's not quite right. Oh, last num is v of j. Oops. Greater than or equal to 100. There we go. That's a little bit better. Small logic issues. Same thing with greater or equal to 10. Damn, it's already 6 o'clock. Fuck. Time flies when you're having fun. We didn't quite get to where I wanted to get. Well, let's see where we're at, right? Do I have... Oh, I have to specify that. Wait, so we could just say 0. Error. I have to declare it as a fucking mutable. Let's see. Okay, compiled. Hey, dude. Hey, do you, man. No worries. Appreciate you showing up, dope. I'm probably gonna have to get off stream here pretty soon. Either way, thank you for the bits, man. I appreciate that. Shoutouts for the support. Let everyone know that Evil Dojo's writing Quines and Russ. We've got something pretty good here. It's pretty close. We got the top half working, we got the middle half working, and our goal is to make this area output just like on top. Have a good rest, dope. Take it easy, man. Let's clean up some of the code while we're here, now that we've got it compiling again. Okay. This looks pretty nice, but it's still not exactly where I want it to be. So may not even necessarily need to do any handling of the new line stuff. In handle array spacing, we're still passing new line count off to it. This may not be necessary. So we may end up being able to get rid of passing new line count to print array, but it's possible that, you know, some of the logic floods into one or the other, so it's definitely considerate to try to have it in both places. One thing that we had here that was working was that we're getting the rule to trigger for this case, but adding in adding the I back in causes it to no longer trigger. We actually don't care about current row here, because we already know. Well, it's possible we don't know. One thing that we do want to do when we switch out of these modes is not lose track of the eye. Um, so else if line count less than or equal to max rows and star I greater equal to column length. We'll set it up as its own check here. I shouldn't have to do that, one would think, but we need some separation of components here, because if the new line count is changing in the middle of incrementing our index, then we might be losing track of something, which is why this never triggers with the eye properly. So this is never triggering because I is never getting a chance to get to this point. We could actually check whatever the value of current column was. Okay, so that doesn't quite work, and it does something interesting on the right-hand side. It's now splitting on almost like every, non-white space, or on every actually white space that we encounter. So not quite right. We can leave it like this for right now, but it's not exactly where I want it to be. All right. 6:15. Um, I've got 3 dogs to feed, 1 dog to take out to pee pee and poo poo, 1 grandma to make sure that she's not too hungry. Um, we've got leftovers, so thankfully making dinner is going to be rather easy. I want to get back to this and actually get the bottom working, which I probably will get it working off stream, and then I can pop on stream and show off what I did there. Um, at that point, it might be a good time for a blog post about it, just to showcase, everything I've picked up in Rust so far. It's not like I'm doing a whole lot of crazy shit. We're just literally doing some academic Quine writing right now. I hope y'all enjoyed. If you like seeing programming and shit, come hang out, come check us out. We doing this thing. Got a lot more stuff on the way in the future. 2024 is looking like a rusty year to me. I don't know about y'all, but I'm kind of digging it. It took a while to rub off on me, but I get it now. Let's stick to it. Dark Mage out.